Okay. Hi guys. I am okay. There we go. Okay, so we are covering chapter 4 tonight. Um, everybody's gonna kind of hop on and get everything going. Um, and so with this one, this chapter doesn't really go with anything else. I mean, it's kind of a standalone. This is a chapter that in some books is put closer up by like where we did probability, kind of after we did like standard deviation and variance and all that kind of stuff. So some textbooks put it up there, and chapter-wise, that's where this was done at. They did it back up as chapter 4, which was right after we did all the stuff. Where it hits in sequence, pretty much what happens here, sorry, I'll try and make lighting a little better. One of the things that kind of happens is this chapter deals with 2 variable setups, okay? And so everything else we've done has been 1 variable. 1 data set, all of that kind of stuff. So this is the first one where we are putting kind of an X and a Y, or 2 things, and we're going to link them together. And so with that, we're going to talk about 2 things. We're going to talk about number 1, the kind of the first section that we have to do, and the setup for this is we only have 2 sections to cover in this. Okay, so there's only 2 sections in chapter 4. The 2 things are, the first thing we're going to look at is there a relationship between these 2 things? Okay. And if there is, how strong is it? Okay, is it, are they kind of just, there's not really something there, there might be a little bit of something, but not really? Or is it, yep, I can pretty much tie these 2 things together, that like if one goes up, the other goes up, or if one goes down, the other goes up, you know, whatever that relationship is. And then 2, kind of the second section that we're going to do is, we're going to be doing kind of a line of best fit, okay, kind of the best equation that can go through this stuff. And we're going to be using that to do a little bit of predicting, okay, as we process through. So the first thing that we're going to talk about, and I'm going to switch over here to my other view. There we go. So the first thing that's going to come into play, I'm going to try and get myself reset up here. Okay. Okay, so the first thing is what we call a scatter plot. Okay, so now with a scatter plot, if you were given points like 1, 2, 2, 5, 2, 6, 3, 7, and 4, 9, okay, and we were to go onto a grid space, okay, quite literally, all we would do with this is I would go to 1, 2, and I would put a dot. I would go to 2, 5, and put a dot. I would go to 2, 6, and put a dot. 3, 7, and put a dot. And 4, 9, and put a dot. That's a scatter plot. Do not play connect the dots, okay? You want the stuff to sit as individual points so that you can see whether or not there is a pattern there or not, okay? So kind of where this is headed is, number 1, with this particular one, I can see a pretty good line, okay? Like I can see there's the relationship kind of right there going that direction, okay? Now, what we're going to do in the second section is we're actually going to try and figure out what does that line need to look like, okay? But more on that when we move over to that particular section, okay? So that's a scatter plot. Now, the next thing is that when we talk about scatter plots, okay, we want to talk about kind of how they are put together, okay? Now, if you look at the PowerPoint, okay, they talk about, they make all these big charts and diagrams and wordy things and all this kind of stuff, okay? Here's what you need to know. Positive linear association. Okay, what this is going to look like on a scatter plot. Okay, positive means it's going up a hill. Linear is it's a line. Okay, so positive means we're going up a hill. Linear means it's a line. Okay, now you can also have negative linear association. Okay, so big shocker here. It's going to look like a line and it's going to go down a hill. Okay. Okay. Now, one of the things that they will sometimes say about this, okay, just so that you have, I can't go too far. Okay. Okay, now with a positive linear association, as one number goes up, so if my x's down here are going up, then so are the y's. Okay, so if I go to an x value that got bigger, then the y value is also sitting. So if I picked one here versus one here, this answer dot, okay, goes, and so you're going, now you could also read as one goes down, the other goes down. It's that both of these words do the same thing. Okay, now with the negative one, this is going to be as one goes up, the other goes down. Okay, so notice here, as my x's go up or get bigger, the y values are decreasing or coming down. Okay, so sometimes they'll ask, you know, as one goes up, what does the other do? So in a positive linear association, as one goes up, the other goes up, and as one goes down, the other goes down. Now then, a couple of things that you need to be aware of, okay? And as we are proceeding through this section, okay, we're going to be focusing on linear things, okay? Now, a couple of things can happen with this. One is that there's actually just nothing there. Okay. One option is there is no relationship there whatsoever. Okay. Now, the other thing that can happen okay, is that there is a relationship there. It's just non-linear. Okay. So now the other thing that's going to happen here is as we're processing through the math and the formulas that we are going to be using for this stuff, okay, cannot tell the difference between these two, okay, because this is, there's not a line, this is also there's not a line, okay, so all this thing tells us is if there's a line and how good of a line it is. It does not know the difference between the two of these, okay, so just because you get that there's not a line shape does not mean that there's not a shape at all, okay? It just says it's not the straight line shaping that we're doing, okay? So now then, the thing that's going to come up, Okay. Okay. We are going to be looking at the correlation coefficient. Okay. Now, what you need to know, this is going to tell us two things. Okay. One is how strong of a linear relationship okay, so how strong of a linear relationship. The second thing is it's going to tell us the direction of the relationship of the line. Okay, so what that means is, okay, you're going to get a correlation coefficient that may be something like 0.723. Okay, now what you need to know is the closer this number is to 1, like the whole number 1, the stronger the line is. Okay, so this is fairly strong because it's a 0.7. Okay, so that's pretty close to 1. Okay, the other thing is it's positive. Okay, so that means if I had my scatter plot, this little bugger would be going up a hill. Okay, now if I had something like this, okay, first off, this is kind of moderate. It's kind of in the middle. Okay, now the negative here I don't care about. Okay, the only thing I worry about for how strong it is the numbers part. Okay, so I'll look at the 497. That it's moderate. It's kind of in the middle. It's those middle values like 4, 5, and 6. Okay, the negative tells me that it's down a hill. Okay, so if we were going to look at a picture of this, maybe it looks like this. Okay, I can kind of see a general downhill direction. The dots are a little spread out. Okay, so I have kind of a basic idea where the line is, but it's not necessarily a great line for what's going to happen. Okay. Now then, I'm going to put the formulas up. Okay. For this. Now, this is something that can be done on a calculator, and I'm going to handle that here in just a little bit. Okay, so we're going to talk about how to do it on a calculator here in just a minute. Okay, but I am going to show you the formulas for it. Okay. Now, there is okay, now this formula looks pretty, okay? But guys, the same way that we had over in when we did like chapter 3, and we had kind of some pretty formulas, but they weren't easy to mess with computationally, the same thing's going to happen. So if you're going to do by hand, okay, and I'll move this over so that you can see what I'm fixing, okay? There we go. Okay, let me see if my camera will refocus on my stuff. Okay, so let me explain what's going on with this, okay? So what we're gonna need to do, and this would be done in a table, and I'm gonna show you one of these things run way out, okay? This is, I need to do X times Y, okay? And that's the summation symbol right in front of that, okay? This is the total of just my X values. This is the total of just my Y values, okay? N is your number of data points. So down here, I've got my number of data points. This is X squared, okay? So we're gonna total up the X squareds. This is the same total of the X's that we had up here, but that value is gonna be squared. Difference here. I am squaring my numbers first, then adding them. This is I am adding the numbers up and getting a total and then squaring them. And then we do the same thing over here. We do Y squared. So we're going to square the Y's and then total it up. This is I'm going to total the Y's and then square them. Okay. So I'm going to pull an example. Okay. And I'm going to work this out down here. So I've got X's and Y's. Then I've got 6, 1, 4, 7, and 3. Then I've got 2, 4, 1, 7, and 6. Okay. So here's what we're going to do. I'm going to extend my table. And now I'm going to do X times Y. So I'm going to do 6 times 2. That's going to be 12. 1 times 4 is going to be 4. 4 times 1 is 4. 7 times 7 is 49. And 3 times 6 is 18. Okay. Next thing I'm going to do is I'm going to do my X squared. So we're going to do 6 squared, 1 squared, 4 squared, 7 squared, and 3 squared. And then I'm going to do Y squared, and I'm going to do 2 squared, 4 squared, 1 squared, 7 squared, and 6 squared. Okay. Now, the only other thing we need to do is we're going to total all of this up. Okay. So that's going to be 10, 20, 21. Let's see, 7, 8, 10, 20. Let's see, 12 and 18 is 30, so that's 79, 83, 87. Let's see, 9 and 1 is 50, 86, 96, 102, 111 for that. Okay, and then 20 and 50 is 70, so it's going to be 106 for that one. Okay. Hopefully everybody's tracking where I got all those numbers. Okay. Now what I'm going to do is I'm going to bring these up. Okay. Because I'm fixing to plug these into formulas. So this was my summations line. And 20 and 87, 111, and 106. Okay. And now we're going to plug these into formula. Oh, there was, N was 5. Okay, there were 5 data points in that list. Okay, so now plugging into formula, we're going to have 5 times 87 minus 21 and 20 over square root of 5 times 111 minus 21 squared, another square root with 5 times 106 minus 20 squared. Okay. And again, I'm using that by hand formula for this. I will show you here in just a second how all of this can go in on a calculator. Okay. So now, running numbers, okay, this is going to be 435 minus 420 over, it's going to be 555 minus 441. And this is going to be 530 minus 400. So all I did was my multiplications. Multiply, 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 square, okay? That's all I did here. Now I'm going to do each of those subtractions. Okay. Now I'm going to do the square root of 114 times the square root of 130. And I get 121.737. And now I'm going to do 15 divided by that. And I get 0.123. Okay. Hopefully everybody can kind of track with that. Try and straighten all this up. Okay. Now then, with this, okay, kind of going back to our stuff. First off, it's positive. It's a positive number, that means it's going up a hill. But there is not a whole lot here, okay? This number is not very high, okay? It's actually a whole lot closer to 0, which is no relationship whatsoever, than it is to 1. So this would be one of those things where these were really just kind of random dots on a page, okay? And there really wasn't anything there, okay, to kind of go off of, okay? There really just wasn't anything. They were kind of grasping at straws to make any of this stuff go together, okay? Now then, taking a look at number 2, it says determine whether the association is positive or negative. Now this is going back to that idea of positive is when one goes up, the other goes up, or when one goes down, the other goes down, either or. The other one for negative association is when one thing goes up, the other one goes down, okay? So it says the number of hours a student spent studying in the past 24 hours and the number of hours a student spent sleeping in the past 24 hours, okay? So the idea here is, guys, okay, if the number of hours I spend sleeping goes up, then I am taking hours away from the time that I could be studying, okay? So for example, if we were to say I'm going to sleep for 4 hours, that leaves another 20 hours for other stuff, including studying. But if I'm going to sleep for 8 hours, that only leaves 16 hours, okay? So as the number of hours sleeping goes up, the amount of time that I've got for the other stuff is down, okay? So that is going to be a negative association, okay? So because when one goes up, the other goes down, okay? So hopefully that kind of makes sense. Now, for the, okay, I'm going to clear this, okay? We're going to talk about a couple of properties, a couple of them I've already said, okay, of our correlation coefficient here, okay? And I'm going to zoom in on these, so don't worry, give me just a second. Okay, here we go. So now the correlation coefficient, which is that R thing, is always going to be between -1 and 1. Okay, now here's the deal. The negative only tells you direction. That's it. Okay, so if I have a correlation of 0.8 that's positive and a correlation of -0.8, the only thing that changes is the direction. One was going up a hill, the other was going down a hill. Okay, they are the same strength because they are both 0.8. Okay, so the decimal number is the thing that decides strength, and it doesn't matter. Again, the positive and negative only tells direction. Now, correlation coefficient does not depend on the units of the variables. Okay, so if you're measuring something in miles and somebody else does it in feet, doesn't matter. The correlation coefficient is not going to change. It doesn't matter what your x and your y variable is. okay? Doesn't matter if one of them's time and the other is distance, and if somebody else did distance and time. Now then, this correlation coefficient only does linear relationships. We are only focusing on lines. That goes back to the idea of this stuff cannot tell the difference between shapes that are not a line, that are a curve, and stuff that isn't there at all. Okay, you can't tell the difference. And then a correlation coefficient is sensitive to outliers. Okay, and so it can be a little, that can kind of throw some stuff off. Now, what that means is, if I have lots of dots in a nice, pretty, compact grouping that looks like this, okay? This may have a correlation coefficient of, I don't know, 0.827. I'm making something up, but it's a pretty good stack, so it's probably going to be fairly high, okay? Now, if you throw in here one dot that's way down here, okay, all of a sudden, because of that one dot, your R value may go down to something like 0.523. And that is because it's saying, well, here was my line, but wait a minute, I got to move this down to try and go grab that single dot, okay? So this dot is going to throw that line off, because now it's saying what was a really good, strong line now isn't so good, because now it's got to try and fit something like up through here, because it's got to bring into account this dot, okay? So now let's talk about how to put this in on a calculator, okay? Now, I'm going to talk to you about what's called turning a diagnostic on. Now, turning diagnostics on only has to be done on the TI graphers. If you are not using a TI grapher, if you're using one of the other ones, okay, please send me an email and I will talk you through how to do data entry into your other stuff, okay? So here's what has to happen, okay? And this is to turn, I'm going to try and put this over here and put it on. So to turn the diagnostic on, okay? So to turn this on, what you're going to do is you're going to press second, and then you're going to press the number 0. So you're going to press second, and then 0, okay? Now, the next thing is you can either scroll down the list, I don't care, or you can press this little X with a -1 button, okay? And if you press that, it is going to push you down to where you are in the stuff that has the letter D, okay? Now, you are going to have to scroll down until you find diagnostic on. Now, there are two. There's a diagnostic off, and then there is a diagnostic on. Make sure that the little arrow is pointing towards diagnostic on, and then you're going to press enter 2 times. It should come on your screen and say diagnostic on and done. Now, once the diagnostic is turned on, okay, it is like a light switch. Once it's on, it's on. It will not turn itself off unless you go turn it off or you go hit the breaker box, okay, which means memory resets, okay? So do not, just don't do that stuff, okay? So now, here's what's going to happen. What we're now going to do is we're going to put a data set in. I'm going to work with the data set for question number 3, okay? Has to do with eggs and milk, okay? And what we're going to do is we're going to go into stat, okay? And we're going to press enter. This should bring you back to your L1, L2 list that we have worked with before, okay? Now what's going to happen is the first item, okay, in this case, they're the prices of eggs, needs to go into L1. I'm trying to see if my calculator will catch this, okay? The second thing, which in this case is milk, needs to go into L2. Okay, so I'm going to bring this over here. I don't know if this will zoom in well enough for me. Nope, it's not going to do it. Okay, so I'll bring it down here in just a second. Okay, so I'm going to bring this down so that you can see. Hopefully it'll clear up here in just a second. Okay, there you go. Okay, so you should be able to see that eggs is my stuff over here in L1. Milk is my stuff over here in L2. Okay, and I do have, there is one other data point that is right off screen. Okay, now you do need to keep them partner paired together. Okay, so you can't just go putting in, don't like order the lists or anything like that. Just put the data in the way that it comes up, okay, and bring it on. Now, the next set of steps that you're going to do, okay, is you're going to hit Stat, like we've done before. We're going to go over to Calc, and you are going to be picking option number 4, okay? We're going to be picking option number 4. It should say LinReg, okay? And we're going to press Enter. Now, some of y'all may only have to press, it may like pop LinReg on your screen and it'll say L1, L2, and you're just going to press Enter and it's going to go, okay? Others, you may have exactly what I had on my screen, which is you've got a bunch of enters that you have to press, okay? Now, here's the deal. Your R value is this very, very bottom one. Now, we're going to be using some of this other stuff later, okay? But for right now, the R value is the very, very last one down here, okay? So the correlation coefficient for this would be 0.26306, okay? Or however many things that this would be done, okay? However many decimal places they ask. Now, one of the things that this tells you is this is positive, which means if the price of eggs goes up, we anticipate that the price of milk goes up because what one does, the other does. In positive association, what one does, the other does. So if eggs go down, milk goes down. If eggs go up, milk goes up. If we were in a negative one, they do the opposite of each other, okay? They do the opposite of each other. Okay, so hopefully y'all are good with that. I'm going to move that out of the way. And I'm going to bring back over the PowerPoint here just for a couple things so that you can see what's going on here. Okay, if R is positive, then it's a positive line. I told y'all that. If R is negative, let's see if my phone, come on. Sorry, I'm trying to let it not be blurry. If R is negative, then it's a negative association. If it's close to 0, then there's not a real good relationship. The closer you are to 1, the closer you are to positive 1, the more perfect the line is. Okay, now if you can get 1 spot on, like if it tells you R is 1, that means take a ruler and play connect the dots. Every single one of those dots is going to be exactly on the same line. Like take a ruler and go. If you're getting closer to -1, then that means it is in a negative shape, but it is becoming a stronger negative relationship. Again, if you get -1 spot on, put a ruler on it, you've got every dot is on a perfect line. It's just a down a hill line, okay? And again, the computation for this, calculator or by hand, cannot tell the difference between there's nothing here at all or there is some other shape, okay? Now, one of the other things that has to be discussed, okay, is correlation does not equal causation, okay? Just because two things are connected does not mean that one causes the other one to happen, okay? They can do some sort of, so one of the examples that they give, okay, is they gave a group of elementary school kids a vocabulary test. Like, how well do you know these words? And they also measured the students' shoe size, okay? What they found was the larger the shoe size, the higher the score was on the vocabulary test. Okay. Now, does that mean that as my foot, okay, so that somebody with a really giant foot is automatically going to have a really good vocabulary? And the answer is no. Okay. You may have really tiny feet and you have an excellent vocabulary. Okay. Those two things, just because I can show that they were related or connected, does not mean one causes the other one to happen. Okay. In order to show causation, you have to do some sort of an experiment. Okay. This is literally just checking to see if there is a connection. Okay. We could do something like how many dogs I have and my grade in stats class. And maybe I figure out that the more dogs I have, the lower my grade is. Okay. So if I have 5 dogs, does that mean I'm automatically going to do poorly in stats? No. Okay. I may do really well in stats. I may have no dogs and not do well. Okay. So you can't say that just because two things are connected means one causes the other to happen. Okay. So just be very, very mindful and watchful of that. Okay. So now then, let's take a look, moving over into our next section. So moving over into 4.2. Okay. We are now going to talk about what they call line of best fit. Okay. So moving over, get rid of this. Okay. We're now going to talk about, it's called either a least squares regression. Okay. So we're going to talk about a least squares regression line or a line of best fit. Now, we are going to allow the calculator to do all of the computation for us because it's already done it. Okay. It has already done all of this. Now, I will put the formulas in just so that you can see them. But we are going to allow the calculator to do all the computations for us. Now, the idea behind this is, okay, and I'm going to draw a picture so that you kind of get the idea of what we're doing here. Okay, so I've got this data set. Now, one person may think that that green line is the best line that could be done. Okay, now someone else may come through and go, I don't think it's that one. I think that line should go a little more like that. And someone else still may come in and go, no, I think this line should go there. Now, the question is, which one is the best? Okay, and the answer is the line that does the best is the line that makes the distances from each point to the line, whether they are below the line and having to come up or above the line and having to come down. It is the one that makes those distances the smallest, the total of those distances the smallest. Okay. Now, there are ways to do formulas because we're not going to rough in or put in any extra line stuff. Okay. So the formulas to do this, okay, now for us, we are going to see this as, okay, hint. This is how this is going to come off a calculator. Okay. Now, B1 is the R value times the standard deviation of Y over the standard deviation of x. Okay. This b sub 0 right here is y bar, which is the mean of the y's, minus b1 times the mean of the x's. Okay. Now then, with a calculator, we're going to see this done this way. Okay. Now, I told you guys when we did our calculations just a second ago, when we did this on a calculator, I said we were going to use that other information in a little bit. It's been a little bit. Okay. So now we're going to be using this stuff to figure this out. Okay. So we are going to go to now a couple of other things. Y is going to sometimes be called a response variable or an outcome variable. X is going to be called a predictor variable or an explanatory variable. Okay. So now we're going to talk about putting one of these on a calculator, okay, and then getting our equation. Now, I'm going to put my data set here. And this is number 1 off of section 4.2. Now, guys, they did this one in X's and Y's. When this goes in, we are going to turn them vertical, okay? So I'm going to bring my calculator back over here into screen. Okay. Now, first off, I'm going to talk about how to get and clear my entry. So I went to Stat, and I'm going to press Enter again. Now, I'm going to go up and highlight L2 and press Clear and Enter, and that will clear my list. And then I'm going to go up and highlight L1, and I'll press Clear and Enter, and that's going to clear that list. Now, I'm going to put my X's in L1 and my Y's in L2. Okay, so I'm doing my X's straight across. Okay, and then I'm going to put their Y partner with them. Okay, so do be careful when they give you like these little sideways tables. Okay, let's see if this will refocus here for a second. Okay, now, again, we're going to hit Stat. We're going to go over to Calc, and we're picking option 4. Okay, and again, for mine, I have to press Enter a bunch of times. Okay, now, what's going to happen is, I'm going to move this over. I'm going to bring this down. Sorry, redo. Okay. I'm going to try to write the best I can here. Okay, guys, you're going to put A, whoops, sorry. Okay, you are going to put the A where the A is in the equation and the B where the B goes in the equation. Okay, so I've got okay, so I'm going to bring this, hopefully it'll clear up here in just a second. So our A value was 37209. So I just did 372 and put an X behind it. And then B was 0.2 or 2.5348. So I went ahead and rounded that to 0.535. Okay. Now, if for some reason, okay, if for some oddball, squirrel ball reason, okay, they were to ask you to write y hat equals b, that other format, okay, where they do like b1, what was it, b naught, plus B1X or something like that. What did I say? Sorry, I lost my formula. Yeah, okay. If they were to ask you to do this, guys, take a look. See how this number is in front of X? Just pull the same number and stick it in front of X, okay? All they're doing here is they're putting this thing here, and they're putting this thing there, okay? If for some reason they do this kind of backwards looking formula, just swap the two things, okay? That's all you have to do to clear those out, okay? It's not anything that's designed to be super difficult or anything like that, okay? Now then, if, and I'm saying if, okay, because I have no clue. I just pulled and I saw some of the examples that they gave, okay? If for some reason, okay, they gave you stuff like X bar was 8.8 and SX was 2 and Y bar was 42,000 and SY was 14 and R was 0.8, okay? And they asked you to come up with the equations, okay? If for some reason they did. I gave you all the formulas earlier, but here they are again, okay? So this is simply a plug and chug type of thing. Okay. B naught was Y bar minus B1 X bar. So this is 42,000 minus 5.6 times 8.8. That is 42,000 minus 49.28. Okay, and then again, if they asked you to write the equation following this notation, or if they do it backwards, you're just plugging stuff in. So B1 was 5.6. B naught is this. Okay, and guys, that's if they give you that information stuff, okay? I'm not saying they will or they won't, but they might. Okay, now, one of the other things that can be done is once we have an equation, okay, kind of this line, we can use it to predict. Now, one of the things though, okay, is you can only use a prediction line, okay, for data points that are in or around the original data set, okay? You can only use this to do stuff for things that are in or around a data set, okay? Okay, so we're going to look at an example, okay? And I'm just going to pull our data set over here. We're going to be working on this data set. See if it'll focus in on my document up there real quick. Come on. If not, I'll zoom down on it. Looks like I'm going to have to zoom down. Okay, so let me set this here. I'm gonna come down. Okay, so this information is about budget for certain organizations. This was their budget in 2006, and then this was their budget in 2012. So over here, I'm going to go to Stat and Edit. And again, I'm going to go up and highlight L1 and press Clear and Enter. I'm going to go up to L2 or L1 and press Clear and Enter. And then I'm going to put in this data set. So I'm going to do 460, 295, 18, and 247. And then we're going to go to 444, 2, 128, 23, and 232. Okay, so same data set, just bring it across. We're going to go to Stat, over to Calc, and we're going to go down and pick option number 4. Okay, and again, for my calculator, I've got to press a bunch of enters. Okay, so now notice we've got 0.996. Guys, that is a really good line, okay? Like, really, really good, and it's a positive line, okay? So I'm going to write our equation up. Pull this back up. Y'all are getting to see my lovely desk here. Okay, so my equation, and I'm going to do 3 decimal places. Okay, so here is my equation. Okay, now keep in mind, okay, that X was the 2006 budget and Y was our 2012 budget. Okay, so basically this is kind of based on the information for a 2006 budget, how much would they have in 2012? Now, we had data, okay, our X's went from 2 all the way out to 460, okay? Which means I do not need to be using this to predict for somebody who had, say, 750, okay? So I can't use something like let X be 750. I need to stay inside of this 2 to 460. I may can go a little up, so maybe I can go to 500, maybe 550, but I don't need to go too much further out than that, okay? For that. So I can do something like predict the 2012 budget if the 2006 budget was 502 million. Okay. So guys, what that means we're going to do is we're basically plugging in 502. Okay, and what we get is that it would be 482.845. Bring that down a little bit more so you can see. Okay. Now, this is the predicted budget for 2012. They may not have gotten 482 million. Okay, I think all of this was in millions. They may not have gotten that amount. They may have gotten 500 million. They may have gotten 480 million. This is just the estimate based on the data stuff that we were given. Okay, so make sure that you are being cautious with that. And again, that's why we can't go too far outside of the realm of where they did, okay? You can't go pushing way, way far out. One of the other examples that I remember seeing was they were talking about, it was like how much money salesmen sell, like amount of sales in a month based on how long they had been with the company, okay? And they did, the data set had people had been at this company for a year, all the way up to about 15 years or something like that, okay? And so they had this stuff, and it was a positively associated thing. The concept being that the longer I've been at a company, the more familiar I am with their products. Maybe I've got customers that are coming back to me that are ordering again, things like that. I'm just getting more experience as a salesperson, things of that nature. And they asked, predict what it would be for someone who's been with the company for 30 years. And the number was like obscenely large, okay? Like in a month, this person was supposed to sell like $1.2 million, okay? Everybody else was down in like 60 or 70,000. Okay, like it was obscenely big, okay? And it's because the original data set only went from like 1 to 15, and now you were jumping all the way out to 30. You can't jump like that, okay? It would be the same idea as if I was doing a growth chart for a child. Children do not grow the same way, okay, from the time they're born up to like, I don't know, they're 10, 12, something like that, to that they're not keeping that same growth pattern when they hit their mid-20s, okay? I can't expect that a child grows the same in their, when they're in that 6, 7, 8, 9, 10-year-old range as they are when they're 26, 27, 28, 29, something like that. It's just not going to happen, okay? So you can't use one model to predict farther outside and away from the other stuff. Now, one of the things that also happens, okay, is they ask you to interpret, okay, kind of these two values, okay? Now, with this, okay, and I'm going to use this one for example, okay? This number, okay, which is what's called your y-intercept. If you think back to an algebra setting for that, this would be the amount that you have when x is 0, okay? So for example, with this interpretation for this problem, if they did not have a budget in 2006, so they had 0 here, in 2012, they would have 11.47 million, okay? The other, okay, is they ask you to interpret this, okay? Now, the way you interpret this is you say for every 1 increase in X, so in this case, it would be for every $1 million increase in the budget in 2006. So I went from 2 million to 3 million, or 5 million to 6 million. This is the increase or decrease. This is the amount of change in the 2012 budget, okay? So it would be, you would get 0.939 of it. So you've got to kind of watch the way that does. And with budgeting stuff, it does seem a little, a little bit strange for that. Again, okay, so going back to the one about like I was talking about the children thing, it would be something like, so let me give an example here. Okay, so I know he was 49 inches tall here. He's put on another 3 inches now. At 2, he was 33 inches tall. Okay, so maybe this is how old a child is and what their height is. Okay, so I'm going to run this through an equation real quick. Okay. Oh, I didn't do that with this. Okay, so now let's do the interpretation here. Oops, sorry, went the wrong way. Okay, this would be, okay, height at, and so since X's are this, age 0. Okay, so this is something like how tall this child was when they were born. Okay, now what this is the amount of height gained, again, because it's positive, in 1 year. So for every 1 that the X goes up, this is the amount that the Y goes up. Okay, and if it was negative, then it would be the amount that the Y goes down. Okay, so this is the amount of height gained in 1 year. So basically, I could kind of fill in the gaps and say, okay, if they started at 27.821 and I added this on, okay, at 1 year old, they would be 30.6. Okay, again, I could put in the number 1 right here, and it would be 30.6. So I could use it to kind of fill in some of these spots on the table as that goes through. Okay, so that is the end of chapter 4. Again, if you have any questions at any point in time in the homework stuff, please feel free to email me, message me in Canvas. I am trying to be as prompt as possible with those responses. I also put an announcement up yesterday about, I'm going to get some information out to you. It's probably going to be tomorrow. Maybe I'm hoping to have it out tomorrow about how we are going to be doing testing stuff. Since now we are not going to be able to get back in time. I'm going to sort out how we're going to do the testing situation, and also give you some timeline on when that's going to happen. And I will let you guys know when that's going to be, kind of what that's going to look like, all that kind of stuff. I will also probably post a video that talks about the project, because we still have to do the project. And I will put that out. I'll put that also in like the Zoom links or something, and I'll name it, discussion of project, something like that, for that, so that you know what's going on with that. So hopefully these have been helpful. Again, they're all going to be on YouTube, so if you missed something, want to go back and listen to something, all that kind of stuff, it will be there. And like I said, if you've got any questions, please don't hesitate to contact me. I will try and get back to you as quickly as I can and try and make it make as much sense as it can. So I'll see you guys later.